Hello, Mr. One, right? Last lesson we talked about finding the strongest team among these n teams, right? There are n teams, champions from 0 to champion. Okay, so from 0, the team from 0 to n-1. Okay, we're given this graph last time. So this is the directed and weighted graph, and we guarantee the graph given has only one strongest team. Okay, so if team A wins team B stronger than team B, it's guaranteed team B is not stronger than team A. If team A is stronger than team B, if team B is stronger than team C, we can guarantee team A is stronger than team C. Okay, the first solution is to we compute the integree. Integree basically the number of incoming edges for any vertex, and then the strongest team is the vertex, is the team with 0 incoming edges, so it's 0 integrate. The other way, basically these two ways, is to count the number of the ones in a given adjacent metric. If it's n-1 ones, it means that the team is stronger than the other n-1 ones. Okay, so then it's a strongest team. There could be multiple strongest team. Okay, for example, like we're talking about this graph, which is also a directed acyclic graph. Okay, directed acyclic graph. It doesn't have a cycle. Okay, cycle. This is cycle. Okay. So what defines a cycle? If a vertex, right? If a vertex following the edges can come back to itself, then we have a cycle. We don't have a cycle in this case. DAG is like that, right? 1, 2, 2. 1 is stronger than 2. 2 is stronger than 3. And how about if we have like 4 is stronger than 2. 2 is stronger than 3. Okay. So in this case, we have two vertex which are 0 in degree. Okay. So in this case, we need to return -1. So in other words, we want to find out if there is a unique team which is stronger than n-1 teams. Otherwise, we return -1. Okay. Similarly, we want to find the strongest team, but we might be given a directed acyclic graph by something like that, which we have multiple strongest teams. So, what's different? We can apply the same algorithm, right? We compute the integrate for each vertex, and then we find out, we just filter out the vertex which has the 0 integrate. And we find out, we just check if they are 1 or more, right? If they are more, then we return -1. If not, then we simply return it. But we are given these edges instead of the adjacent metric, right? Edges. So what's edges? Edge is an array of like A, B, something like that, right? So it means that A has a directive edge to B. Okay, so we need to change this slightly. For A, B in edges. Okay, edges. We don't need this. Then G, B plus equal 1, right? Because if we have a vertex coming from A to B, then the integrate for B needs to be incremented by 1. Okay. Then we just fill out those edges, right? X equals I for I in range n. Okay, we're given an n here. If gi equal 0, then we have to check, right? So if length x is bigger than, if length x is bigger than 1, then we return -1. Okay. If x is bigger than 1, or length x is 0, right? If we don't have such strongest team, we can invert this condition. So we check if the length of x equal 1, then return x 0. Otherwise, return -1. That's it. So today, similarly, we given this graph with a directed acyclic graph. The only difference is that we may have multiple vertex which have 0 integrate, and we want to find out if there's a strongest team. The strongest team is defined as the unique vertex which has only 0 integrate. Okay, so the first step is the same. We iterate over the edges, A, B, iterate over the edges, and we update the integrate, which is this B, Indegree plus equal 1. And then we collect, we filter out, we find out how many vertex have 0 integrity. If it's length 1, when we turn it, this is the unique, which is the strongest unique team. Otherwise, we return -1. The other way is that, we want to find out the weakest team, right? So look, if B is the weaker team, okay? So because it loses at least to one team. Okay, so weak team is a set. B, okay, B. For A, B.
It doesn't mean if it loses, doesn't mean it's weak.
Okay.
It just means it's just loose.
Okay, yeah, sure. Do you understand it? Weak. This is curly brace. So it means that this is a set. B. For AB is the edges, right? A has a directed edge to B in edges. So B, we're collecting the vertex which have incoming edge, incoming degree. Okay. So if there are n teams, how many teams are weak if we only have one unique stronger team? There are n teams, and how many teams are weak if we only have one strong team, one champion? Simple math.
But other ones.
Sorry?
But other ones.
Other one, which is?
N-1.
That's right, yes. So look, then we check, right? If the length of weak, if it's smaller than n-1, then we return -1, right? Return -1, am I right? Right? Look, the length of weak team is not -1. Then it's not n-1. Then there must be multiple strong team in this case, yeah? Multiple, yeah?
Does it have to show all of it? You see that diagram there?
Yeah.
Does it have to show like all of the matches?
All the matches. What do you mean all the matches?
Yeah, does it have to show all of it? Does it have to show like does it have to be an arrow between every single?
No.
Oh, does there have to be an arrow in between
Every other, right?
Yeah, every.
So if the edge from 1 to 2, 1 is stronger than 2.
Yeah.
2 must not be stronger than 1.
I know,
Uh-huh.
but
It's connected. It's connected.
I know it's connected. I'm saying, does it have to all be connected?
Yes. You can't have another edge is 5, okay? And then it's disconnected. This is
No. I'm just saying in every combination.
no. Because if every combination, that would be having a cycle, right? We can do the math, right? Look, there are n vertex. That's a very good question. There are 4 vertex. How many edges we need to make it connected?
5.
1,
5.
2, 3. Any more edges will make it a cycle. Okay, if there are n edges.
How would it make
But
it
there's
a
one
cycle?
up there, there's one up there.
Okay, so
See,
now
there's one up there.
what do you mean? Come on.
Up there, see.
How would it be a cycle because
Not all
it
the edges
depends
are
on the
connected up.
arrows. It depends on the arrows.
It doesn't matter.
No, it depends on the wings.
Okay, so can you draw something that?
It depends, and you're saying that is a cycle.
No, this is not cycle. Forget about this. Here.
Yeah, you said if it's all connected, then it will be a cycle.
Okay, this is not a cycle. There's no cycle here.
No, I said you said that if all of it is connected, then there wouldn't be a cycle.
That's
Then
right.
There would be a cycle.
Uh-huh.
Yeah, that's what you said.
Okay,
That's what
okay.
you said.
Okay, let me rephrase it. Okay,
You
for n vertex,
that's what
we
you
only
said.
need n minus 1.
That's what you said.
Okay, for n vertex, we only need n minus 1 edges. Am I right?
Does it all have to be connected?
Yes.
But that's not.
Yeah, but that isn't.
This is connected. Why is it not connected?
No, I'm saying all connected.
That's not all connected.
Why is it not all connected?
Yeah, it isn't all connected. Like this isn't connected to that.
Okay, in a graph, connected. This vertex can go to this vertex.
No, I'm just saying like does I was saying before like does there have to be every match of every combination?
Every matches. No.
You literally said yes.
If please, this is 1, 2, 3, 4. Okay.
You
So-
give me arrows.
Okay. In directed graph, because there's a direction, so maybe we don't say connected, right? For example, like left. Here, this is a special case because there's only one edge between 2 nodes. Either A wins B or B wins A. They will not be bidirectional. So we talk about the connected is that, treat it as undirected graph. Okay? If there are n vertex in the undirected graph, if there are 4 vertex in the undirected graph, we only need 3 edges to make it connected. One more edges will make a cycle.
It wouldn't make a cycle before because it depends on the arrows.
Okay, that's what I'm saying. Forget
Yeah,
about errors.
No,
Yeah,
you didn't say that. You literally lied. You literally said that if there was another one, then it didn't.
Okay, now I get your
just
point.
like 10 seconds ago, and then I said, oh.
I will check the video. I will check the video.
You literally said that. You
Okay,
literally
okay,
said
but now I get your point.
It depends on the arrows. You didn't say that. You were saying that. That's what I said when you didn't.
Okay, so here is a special case because,
No,
as I said, yes, it's directed. But we can treat it as undirected. Why? Because there's only one edge, one direction. It cannot be, A goes to B, B goes to A. Okay? So,
yeah, but that.
either this or that. Okay? So we can just unify it as an undirected graph. What I'm saying is that in the undirected graph, there are n vertex. We only need n-1 edges to make it connected. Okay? Forget about the direction because, direction is, there's
No.
only one edges between any 2 vertex.
I was just saying
Yeah.
before that.
Does it have to be a combination?
Yeah, that's what I was saying before. And then you said, oh, it's no, and then.
3 nodes. How do you have every combination? What do you mean every combination?
It'll
1
be-
to 2.
Yeah.
2 to 3.
Yeah.
Okay, and then?
And then it'll be 1 to 3.
No, it can't be 1 to 3.
Why can't it be 1 to 3?
Because then it won't be a cycle.
Okay, so 1 to 3. Yes, this is not cycle, but it's not.
Yeah, that's what I said. You
But
did-
remember, the problem, as I said, Team A wins Team B. Team B wins Team C. Team A must win Team C. So we know for sure. Okay, we
No,
know
because,
for sure.
No, because team 1
And
wins,
what's the problem?
against
What's the
team 2,
problem of a
Yeah.
cycle?
and then team 2
Yeah.
wins team 3.
Yeah. Then
And
Team.
then at the very beginning, you said if in this kind of scenario, then team 1 wins against team 3.
That's right. Yeah.
Yeah, that's what I said.
Okay, so
And then you rubbed it out.
that's for sure. 1 wins 3. That's for sure.
Yes.
Okay.
Yeah, so what were you saying about it?
What's the original argument? I forgot.
Yeah, no, that's not an excuse. That's an excuse. Because look.
Oh, yeah, we're talking about this.
You literally rubbed it out, even though you was agreeing that it was correct, and then you rubbed it out.
Okay, so look, 1 to 2, 2 is the weakest. 2 to 3, 3 is the weakest.
No,
if you
it
have
isn't.
1 edges, then 3 is also the weakest. It doesn't matter because weak is a set, so it doesn't matter.
Yeah, no. And when you said 1 to 2, 2 isn't the weakest, and also you're saying that how it doesn't have to be every combination. So that thing doesn't actually count because you said that it doesn't have to have every combination. I was saying that every match, and before I asked you a question, and you said it doesn't have to.
So you're saying 1 to 3 doesn't have to.
No, that's what you said.
Yeah, because we don't have 1 to 3 because we know for sure 1 wins over 3.
Yeah, but if you look at it, 1 to 2, and then 2 to 3, and then you and then why can't you put 1 to 3?
Okay, yeah, fine. 1 to 3, that's fine.
Yeah, for example,
1 to 3, that's fine. Yeah, it doesn't change the result. It doesn't change the result. It's fine.
you can see visually because it's much easier because you see one has 2 wins.
Mm-hmm.
You was talking about the out thing, wherever that is, and then you can see 3 minus 2 is 3 minus 1, so you can just say 1.
Mm-hmm. Yeah, I agree.
Yeah, but you were talking about you're talking about you don't have to have it.
That's right. I don't have to have it. Yeah, that's right.
Yeah, but it's much more easier because you can see it.
Yeah. But there's a problem if 3 wins 1.
Then it was a cycle. I know.
That's right. That's a
I
cycle.
know. You've been
Okay.
Oh my god.
Okay, yes, you are right. Okay, so weak team, okay, you understand this bit, yeah? Weak, we collect the vertex which has at least 1 loose. So weak is the team, is a set which has lost to any other team. And then if the weak team is not n-1, it means that we have multiple teams that has 0 in degree. Multiple team, 1, 2, has 0 in degree. Otherwise, how can we calculate this stronger team? We know the weak team. The team is from 0, 1, 2 to n minus 1, right?
But before, you were saying that one, you know, that diagram one, no, that one. Yeah, this one. You were asking me what goes in between 1 and 3.
1 and 3, yes.
Yeah, that's what you were asking me before.
Yeah.
And then you rubbed it out. So what was the point?
I rub it out, yes, because we are talking about the disconnected.
You were asking me what goes in between 1 and 3.
If you want to put something there, it has to be this edge.
Yeah. That's what I said.
Yeah.
Then you rubbed it out, and you were asking me before that what goes in between 1 and 3.
This edge.
Yeah, no, exactly. But I said that. And then
Okay,
you rubbed
good
it
job.
out.
Okay, good job.
Yeah.
I rub it out for simplicity, okay?
No, but it's not making it more simple because one, I don't understand why you rubbed it out, and two, you literally asked me what goes in between it, and then you rubbed it out.
Okay. As I said, the weak team, right? The weak team, if they are less than n minus 1 weak team, we do 10 minus 1. Otherwise, here we have n minus 1 weak team. So how do we find out the team which is no weak team, which is the stronger team? Look, the numbers are from 0, 1, 2, 3 to till n minus 1. I'm telling you there are n minus 1 team which are weak teams, you know. And I know what teams are weak here. So how do we find out the team which are no weak team? Simple math.
If it's lost one, then it doesn't mean it's weak.
Okay. I mean, if you lost one, you are weaker than the other team, right?
No, not the other team. You might be stronger than other teams.
No, but if in that case,
No, for
then that would be a cycle.
No, it wouldn't. For example, this one.
Yeah.
Then one would be the weak team, and one wins against 0.
Okay. That's very good point. One is the weaker team to 2. 0 is the weaker team to 1.
No, you.
Okay, the team can be weak and
No,
can be strong.
you were saying that. Then it was weaker than the others, but and then it was like it might be stronger than other teams.
My English.
Yeah, great excuse.
My English. Okay, now I get your point. Weak weak means that it has lost at least 1 match.
No, it doesn't.
That's what I'm saying.
No, it doesn't.
What do you mean? Here.
It doesn't mean.
A, B in edges. A wins over B. So B
Big doesn't mean
it has lost 1 match
big
to
doesn't
A.
mean it lost 1.
Okay, it may lost more than 1, at least 1. Okay.
No. If it lost 1, then it doesn't mean it's weak. Doesn't mean it's weak.
That's opinion.
Just
Okay.
change it into something like not champ.
Okay. Thank you. Not champ. Not champ. Okay. If not champ, smaller than n minus 1. Okay. NC. Okay. How about NC? NC. Start for not champ. So okay, as I said, look, there are n minus 1 team. Actually, there are n teams, right? And I'm telling you, we know the ID, the number of n minus 1 teams, which is not champ. So can you figure out what's the other one, which is the champion? It's a simple math, right?
Yeah.
We can just add the sum together. 0 plus 1 plus 2 plus till n minus 1 and subtract the sum of the not champ. Okay? And the remaining is the champ, am I right? Because we only have 1 champ. And all our rest are not champ. And I'm telling you, the not champ, they are n minus 1 not champ. Okay? What's so funny? Okay. So the return, what's the sum of 0 plus 1 plus till n minus 1? The simple math, come on. What's the sum from 0 added up to n minus 1?
Oh,
That's the formula, right?
n minus 1 plus 0 times n divided by 2.
Oh, very good. Someone has listened.
Yeah, you told me like 10,000 times.
Okay. 0 plus n minus 1 times n divided by 2, okay? This is the total sum. And then we need to subtract the sum of all the not cham, okay?
Not
Okay?
It's just like
And then that gives us the only team which is cham. Make sense? Okay? Okay.
No, it's just not it's such a funny name.
Not cham. Yeah, you propose it. Come on, I didn't come up with this name. You proposed this name.
I know, it's like
Not cham. In credit to Eric Lai. Maybe I should, name my Pokemon Unite not cham. Okay? Yeah?
But then you mean you're not the
Oh,
champion.
that's fine. I don't mind. Okay. So are we clear with this problem? Okay. Let me summarize. We are given. This is similar to last lesson. We are given.
There's actually a Pokemon called Machamp.
Okay. We are given.
And it's in Pokemon Unite.
Okay. Let me summarize, please.
Not jump. Not jump.
I'm just curious.
Not jump. Not jump. Not jump.
So today we're given this problem, which is similar to last time. Okay. So we are given n teams, labels from 0 to n minus 1.
What is it called again?
What do you mean?
You said, and it's called blah. I didn't hear it.
Not cham? Okay.
No,
Yeah.
no, you're saying, oh, blah blah blah, and this is called blah blah, and I didn't hear what was it called.
I don't know. I forget. Okay. Let me rephrase or let me summarize.
It sounds like you said. It sounds like you said not last time.
Do you want to summarize?
No.
Think about what the solutions, okay? So today we're given this directed acyclic graph. Similar like last time, we're given n teams labels from 0, 1 to up to n minus 1. We can guarantee that if team A wins team B and team B is not stronger than team A, okay? So there's only one edge. It's a directed graph. It's a directed unweighted graph, but we can guarantee that if team A wins team B is not winning team A, okay? Team A wins team B, wins team C. We can guarantee team A is stronger than team B and team A is stronger than team C. So there's no cycle. So we want to find out if there's unique strong team which has 0 integrity. Okay, so like last time we compute the integrity, which is the number of the incoming edges for any vertex, and we find out those vertex which have 0 integrity, right? And we put it in a list. If there's only one single element in the list, then we return it. This is the unique winning team, stronger team. Otherwise, we return -1.
For example,
Yeah.
let's say
3.
yeah. How would you figure out like that thing?
So the 3. What do you mean? What's the other edges? Yeah.
Yeah.
So 3 has 2 incoming edges. It's not same, okay?
Yeah.
And these 2, that's what I'm saying. It's not unique. They both have a 0 integrity. This is not unique, right? So we have more than one vertex which have 0 integrity. Then we return -1. Otherwise, we return it. And the second method is that we find out that not cham.
But this one will win against this, so it has 3.
Which one? Oh, you mean? I am here another. No?
Yeah. If this wasn't here, and then but this wins against this, so it has 3.
Yeah. Okay. So this has 3. It doesn't matter. 1, 2, 3 wins 3, right? We count the number of incoming edges. If it's 0, then we find out which one is unique. I mean, there are 3, so they are not unique. If there's only 1, then it's unique, right?
No. You just said that if there's more than one, then it isn't unique. But unique means different. And then you said if there's one, then it will be unique. But when it's just one, so it isn't unique.
The stronger team is unique, then we return it. Unique. 1, unique. 2, not unique. Okay?
No, that's not what it means. But if there's 2, like 1 and 2, these two are unique. But
Yeah, these 2 are unique.
you said that if there's 2, then it isn't unique.
We find out the vertex which have 0 incoming edges. Okay, and then if there's only one, then we return it. Otherwise, we return -1. The second method, we find out the weak team, which is not champion. Okay, not champion. And if the not champion needs to be n-1, we can calculate the stronger team. Otherwise, we return -1 because if there are 4 teams and only 2 vertex which have incoming edges, meaning there are other 2 which don't have incoming edges, right? Then it's not unique, then we return -1. Otherwise, if there's only 1 team, okay, so put it this way, there are n teams, and we know n-1 which have incoming edges. Can you figure out the one which doesn't have incoming edges? Simple math, we compute the sum of all together, 0 plus 1 plus 2 till n-1. We know this is constant. And we subtract the sum of the remaining, which have the at least 1 incoming edges. Then the remaining is the one which doesn't have any incoming edges, right? Simple math.
Yeah.
Okay, that's it for today. Bye bye.
Bye.
Bye bye.
Boy.
Bye bye.
Boy.